The main purpose of sampling distributions is to develop what's called a point estimate for a parameter that we're looking for. So the way that we can develop a point estimate, if we take this purple line here to be the sampling distribution for our x bar values, and we're trying to estimate our mu, we can create what's called a point estimate by, we'll say, taking the mean of our sampling distribution, so a value with that line up right around here. And we'll use that to estimate our mu value. To determine the best sampling distribution and its corresponding point estimate, we have two properties that we can look at. First one we can look at is called the bias. And what the bias is, it's the difference between the point estimate for a given sample distribution and the true parameter value. So in this case, for the purple distribution, our bias is much larger than the bias for the green distribution. So in that case, we'd want to pick the green sampling distribution and its corresponding point estimate over that for the purple sampling distribution. The second property that we have is called the variance, and it's the same variance that we've dealt with in previous sections. And what the variance that we're looking for is the smallest possible variance for the sampling distribution that still has a zero bias. So in this example, the purple distribution has a much smaller variance than the green distribution, so we'd want to pick the purple distribution over the green distribution. So what we're optimally looking for is a zero bias and the minimum possible variance. And these are the two properties that we're looking for in our choice of a sampling distribution and corresponding point estimate.